I've separated off the ends that were connected together, and I'm calling these the starts of the coil. Black is usually denoting L1, so I'm going to call this A. So this is A, the start of the coil, and then red is usually L2, which is I'm calling B, so here's the B start, and blue is usually L3, I'm calling that C, so here's the C start. You can see where they start in, and then the ends of the coil. Notice this one is farthest clockwise here, so there's C, and you'd expect there's the end of C. It shares the same slot with B here, and then a couple slots over, then you've got A corresponding with that, and a couple slots over, here's B corresponding with that. And just looking at how the cable or the wires are overlapping, it looks like this is the only one that doesn't have some wires overlapping. So I believe this was the last one that was wound, so I'm going to start unwinding this one. Remember how many turns I've got, and note that I'm going to note if it's clockwise or counterclockwise. So we'll start unwinding, starting with this one. I wanted to record how I was unwrapping these coils, and I saved the last one for this. You'll notice there's a pattern. It goes 3, and then it comes over here, and there's 3 more. This is phase B, and there's 18 total poles here, or slots I guess, and there's 3 phases, so each one gets 6, so I've numbered them. This would be 1, 2, 3, and 4, 4, 5, and 6. So the end is going to be on number 6 here. And so what I ended up doing is I just noted how these were unwinding, and you notice that I'm going counterclockwise to unwind it, so I figure that was wound clockwise. So I label that here's the end, and so I'd label this, say it's wound clockwise, so I'd put a capital B and a 6 for the 6th slot or pole or whatever you want to call it. So then I'd have to count the number of turns. So every time I reach the top I count 1, so there's 1, there's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so I just count that 13, even though it comes back up here. Maybe I should call it 14, but I just called it 13. Alright, and then we go to the nest one, and that's unwinding in this direction, so I figured it was wound in the counterclockwise direction. So I just label it with a small b, and this would be number 5 because we're counting down. So there's 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I've got 28 gauge wire here, and I'm going to try to wind this stator. So I have to start on this end, right by this Hall effect sensor, and I'm going to wind 3 coils, pull the wire across and start winding 3 coils over here. I put this plastic in here just to route the wire around the middle, so when I push this shaft in again, it doesn't get caught underneath this little lip. So that's what this is here for. It's just to route wires across. So I have to start going clockwise. So the wire starts, give it a little slack here, just to the to this side of that Hall effect sensor. Just get a little extra wire in there. I'm going to just tape that down, keep it in place. And rather than just taking the wire and wrapping it like this, I found it twists the wire. So what I have to do is I just have to roll this stator around as I wind. So I just hold that end down. Okay, so there's 1 turn, and then I just have to count. I found that I can only fit 44 turns on here before this thing gets so plugged up I can't get the wires anymore. So I reduce the number of turns. The voltage will go down a little bit, but I think it'll be better than what it was. So here we go. We got 1 turn. Carefully feed it through so we don't damage the insulation. And we just keep going clockwise on this one. Okay, I've got 44 turns on this pole here. And so now, instead of going clockwise, I'm going to go counterclockwise. So here we go. It helps to have a good first layer. There's 1. Okay, so there's 44 turns on each of these. And now I have to move around here to another location. So it looks like we skip 3, skip 1, 2, 3, and then we go to this pole here, and we're going to start going in a clockwise direction. So we got to go to this side and start going clockwise. I just want to double check this because you don't want to have to unwind it. Okay, so then we start going here. Okay, there's 44 turns on each one of these poles here. Now all the starting coils are taped up here, but here we have our ending wires. And the idea is to twist these together, solder them, put some shrink tubing on it, and then stuff it into one of these slots here. And that will hold on to the ends, and that will make our Y configuration. Alright, just soldered on the phase wires here. So this would be B, A, and C. So I just kept the same color combination there. And just put a little shrink tubing on. So next we'll put on the Hall effects and wrap it all up in shrink tubing. I've placed the circuit board so that the Hall effect sensors are in the slots. And And put some 3/16 inch heat shrink tubing over these wires. And just gently tug on these so that we don't have loops in here. Get those lined up. Don't want to break wires, gotta be pretty careful. There's a lot of time invested in this. Okay, that's seated. Pull the shrink tubing down to hold it all in place. Lined up. Okay, make sure this pin goes in here. Line that up with the slot. Okay, this is kind of a press fit, so I have to be kind of careful with this. There's a small shoulder here, so I can't push it in too far, but it is going to stick out on this end. So I made a little sleeve, just printed this up, and I used 100% infill so that it's as strong as it can get. Hopefully it doesn't collapse. So anyhow, what I've got is a little length of threaded rod. This is 1/4 and I just have a little bronze bushing on there so that bronze bushing will sit on the lower surface of this shaft. And then this goes on. Then a washer here. A washer. And a nut. Oops. Wrong nut. That helps. Okay. So the purpose of that little sleeve here is I want to push on the center while I'm pushing this in. If I supported this I guess you'd call it the stator, but the windings on the outside, there's a chance that it would delaminate as it pushes it in. So I just want to make sure that that's supported. Oops. Okay. So I want to do this in a controlled way too, so that I don't hammer on it. Don't like to hammer on things. Okay. Get this centered up here. Okay, that looks centered. Let's start pushing this in. It's going to take a while, but at least it's controlled. I've got some time. I put a little bit of oil on there too, just to help it slide through. Well, that's not good. Had a fail in that this pin fell out while I was pushing it in. So I think what I'm going to do is that just say that this is reasonably lined up with this, and there seems to be enough of a press fit that this isn't going to shift around. So I am going to just leave it as is without the pin and just rely on friction to make sure that this stays in place. Hopefully I won't regret that, but I think that's what I'm going to do. Okay, this bearing has to compress, the inner race kind of compresses the wires in there, and that needs to go down. It looked like it was starting to just slide on. I think the shrink tubing might be getting pinched a little bit. I don't want to hammer it. I always cringe when people hammer on these bearings because you probably Brunel them so that they won't work. You'd have to hammer on the inner race if you want to be safe. But it looks like I can just press this one on. Okay, and then we've got the bearing on this end that has to go on, and I was thinking of just using the same technique. Okay, so we'll just use the same fixture to push the bearing on. It doesn't take quite so much to push it on, I just want to make sure I'm not overdoing it there. Okay, that has to be flush. I don't think I want to go much farther than that, because then it will start hitting the wires. Okay, now that's not quite flush, and I don't know if that's because I didn't push this in far enough or not. I could push it a little farther, but we'll see if this works. Alright, that's on there. This looks good. All effects are on there. So the next task is to get this thing into here. Oops. Okay, so now I have to get this into here, and of course with the magnets it goes in and just hammers really fast. So that's going to be an issue. So I got to think about this for a little bit. Well, I was hoping to catch that on video, but I was trying to lower this in gently using a bearing puller, kind of working in reverse, but it just slipped and dropped into place. The bearing isn't quite seated though, so we know what to do about that. Let's go with this again. This washer is big enough. Put a couple more on. And hopefully just bring this into, or seat this bearing here. I do have a problem though. This bearing I believe is just barely rubbing on some windings, so we might have an issue where it won't, or it will wear through at some point. Hopefully we can get some testing before that happens. But I want to get this on far now so that this side can start seating. Okay. So now this is starting to engage. There's a shoulder on there. And I think before that gets too far, I want to put the screws in and use the screws to seat that. So let's take this out. And this bearing doesn't seem to be that tight a fit in there, so it should be good. But I want to start these screws in and hopefully bring the whole thing home. Gotta get these holes lined up before that shoulder starts seating itself. So here we go. So I have a little adjustment right now. Just kind of get these things in. Get the threads started. Okay, just work a pattern here to try to seat it in evenly. Alright, I tightened those screws up and kind of drew that together. Just got to slide on the urethane outer part here. Put the retaining cap on. Get 3 more screws. And hopefully it will still turn. That's my main concern right now. Just making sure it still spins easily. This cap is fairly trivial, but helps if it's on. Okay. All right. All back together. New windings. If it turns, you'll be able to see if the windings do anything. Alright, so for the cogging, I had this pulley on. Okay, and it drags. This is not good. Yeah, something's not right. It is just dragging something terrible on here. My guess is this bearing is dragging on the windings. That's my guess. That is not going to work. Okay, first problem, the bearing was wearing on these wires. I pried this bearing off. I protected the wires with this tongue depressor, trying to make sure that they didn't get crushed. And I could see there were some wear points right around here where the bearing was. So I just put a little bit of CA adhesive on there, just maybe to give it a little protection. And what I'm going to do is make a shim. I'll go right on this shoulder, and it seemed like a millimeter was appropriate, so I'm going to make it a millimeter thick shim so that when I push the bearing on next, it will be up a little bit so that it will clear the windings. I put a shim, it's a 1 millimeter shim. I don't know if you can see that, but it's just a little orange plastic shim. I should have filmed it, but forgot to. But anyway, the bearing is moving smoothly, and it is not dragging on the wires at all. So that should be okay, but then that's going to make the overall length of the generator a little longer, so we still could have some binding on there. So I'm printing out a second shim that will fit on this flange here, and that will hopefully make the whole assembly a little bit taller. So this one I'm going to make 1.8 millimeters thick. This one was a millimeter thick, so that way it'll just relieve some of the pressure. Maybe there'll be a little bit of slop in here, but I don't think we're going to notice it at all. Okay, hopefully the final assembly. So just fish these wires through here. And this bearing is a light press fit on this. Or I thought it would be a light press fit, but we'll get there. Well, maybe that'll be close enough. We'll draw it together with the screws. But anyway, that's... oh, there it goes. Just need to get lined up. Alright. So that seems to turn well. This turns well. The Hall effect sensors are in place. Now I'll just get the shim on this flange and then drop it in place. I printed out this shim here, and this is about 1.8 millimeters thick nominally. At least that's what the CAD was. Just line up the holes. Last time I tried to just gently put this in, but it just pulled away anyway, so it's probably going to do the same. Okay, so let's see what's going on here. Right, pull it out. Let's see. Okay, I think it just isn't quite on center here. Well, that went a little bit quicker than I thought. I just put it on the stand here and pushed the shaft through, and I was just able to rock it a little bit, and it popped right into place. So now just have to get the shim lined up with this and the holes. Drop in the screws and pull the assembly together. Okay, got that snugged up, and this is rotating much easier. It does tend to make a little noise, but that's I had that before, so I'm not too concerned about it. Then we've got a what it is it's just the magnets. Every time they move to the next magnet, it just sort of vibrates on the thing that's holding the shaft, or keeping it from rotating. Anyway, I can snug that up a little bit and get rid of that noise. Putting the urethane on is pretty much a trivial matter. It's just got this little cover that goes on. And it goes like that. Just put these little screws in place and we will be in business here, I think. I'll be able to check how the generator is doing with the new coils. Alright, so urethane is in place. Put the pulley back on. Very nice. Alright, let's I gotta put the Hall effect, or the connector on the end of the Hall effects here, and then we'll give it an electrical test. I've got one of the Hall effect sensors hooked up. They seem to be working, and I've got the oscilloscope between the A and the B phase here, and you can see the kind of signal we're getting. If I do a single sweep, try to get that fairly consistent. Let's see. We'll zoom in, try to find a reasonably consistent area. I think just the motion of my hand was not steady, so I'll get it a little bit closer here. Alright, we're looking at peak-to-peak voltage of 14 volts and a frequency of 20.3 hertz. Okay, let's just look at those numbers. Peak-to-peak 14 volts, frequency 20.3 hertz. So the peak voltage would just be half of that, 7 volts. And we can convert this to RPM. There are 10 cycles per revolution, 60 seconds per minute. It works out to be 122 RPM. So if we take that ratio, 7 over 122, we get 0.057 volts per RPM. And if we compare that to what our theoretical value is, we used to have 14 turns on there, now it's 44 turns. The old volts per RPM was 0.017. So we just take the ratio of those turns times 0.017, we get 0.053, which is pretty close to that. Also just want to note that the stator resistance is 8.7 ohms. So this is the generator we'll be using for testing from here on out. It's got the new windings, so it should produce higher voltage at a lower RPM, so it will be more suitable for the wind turbine.